This is our lecture number 15, second year math, and today our topic is continuity of the function. And we will start our new exercise, and this is the topic of exercise 1.4. Before solution of exercise, before solution of question, first of all we understand the topic. Then there are two main functions, continuous function and discontinuous function. A function f is said to be the continuous at the number c. Now what is c? C is any constant. It may be 3, it may be any number. If and only if following three conditions are satisfied. If any function is there, it can be continuous if it fulfills these three conditions. And first condition is that f of c is defined. Mean the given function is defined at the given constant, or it is defined at the given number, the value of c. And its second condition is that limit x approaches to c, f of x exists. Now what is meant by f of x exists, inshallah we discussed later on. And its third condition is that limit x approaches to c, f of x is equal to limit x approaches to c, f of x is equal to f of c. Mean that in given function, if we will put limit, then the answer of that function by putting limit, it should be equal to when we put that constant into the given function. Okay ji, we discussed that how function f of c is defined. Then by the following example we can define that how f of x or f of c is defined. Let limit x approaches to 2, f of x, one function is there, f of x is equal to x square minus 4 divided by x minus 2. If this is function, then the value of c is 2, mean the value of x is 2. They are giving that x approaches to 2. If this 2, actually this 2 is constant, c, the value of c, and we can also say that this is the value of x. Then we will put the value of x into the given function. F of 2 is equal to 2 square minus 4 divided by 2 minus 2 is equal to 4 minus 4 divided by 2 minus 2. Answer will be 0 by 0. Now you check that the value of c was 2, but it is not defined because their answer is undefined. 0 by 0 form is there. So this 2 limit is, this function is not defined at 2. Understand? If there is any other number, by putting value of c, if there is any in answer, if there is any other number, it means that function is defined at that time. Suppose that if we are putting value of x equal to 2 and answer is not 0, it may be any constant, it may be any number, then at that time we can say that function is now defined. But you check that when we put the value of c, when we put the value of x equal to 2, then our answer is 0 by 0 form. It means that function is not defined at 2. Second condition was that f of x, limit x approaches to c, f of x exists. What is meant by this? That how it can exist? If limit x approaches to 2 negative, f of x is equal to limit x approaches to 2 positive, f of x. Now what is meant by this f2 negative and 2 positive? Actually this 2 negative representing left hand limit and 2 positive is representing right hand limit. Suppose that if the value of x is 2, then this 2 can be approached from left side, either from the right side. So we will put value in both left hand side, left hand limit and right hand limit. At that time we can say if answer is equal, then we can say that limit x approaches to c, f of x exists. If answer is not same, right hand limit is not equal to left hand limit, then we can say that f of x doesn't exist. Okay ji. And third was that limit x approaches to c, f of x is equal to f of c. Mean if the function that we have discussed already, if a function is x square minus 4 divided by x minus 2, if we will put value of x, if we will put value that is of limit, then our answer is same like that if we put the value of constant into the function, then if both are equal, it means that limit x approaches to c, f of x is equal to f of c. Then if these three conditions are satisfied, then we can say that the given function is continuous. And if any one from these three conditions does not hold, suppose that, like we have discussed, that function, it's mean that f of x is not defined at 2, and same that example we have discussed, if it is not defined but other two conditions are fulfilled, then we can say that function is discontinuous. Understand, student? After that, now we have discussed both function, continuous function and also discontinuous function, that the function is said to be the continuous if it fulfill these three conditions that we have discussed, and if function is to be discontinuous if any one from these three conditions does not hold. After that, we will discuss the graph of continuous and discontinuous function. Then first of all, this is a graph of continuous function. If the graph is showing curve like shape, and it is continuously moving, then that is the graph of continuous function. Like this graph continuous function is also same like graph of sine theta. And secondly, we discussed the graph of discontinuous function. Then you check that first line was going, graph was carry on, but suddenly there is breakage. After breakage, again there is graph, again there is line, after that again there is breakage. It's mean that if breakage is there, if after a little bit movement, if there is breakage, then we can say that that is the graph of discontinuous, because it is not moving continuously. So that is the graph of discontinuous function. And this is also the graph of discontinuous. How? That you check that first of all, if there is jump like in graph, if there are jump like shape is there, first of you can also check that first there is first the curve is vertically, after that it become horizontal, after that again it convert itself into the vertical shape. You know that if we discuss the slope on x-axis and slope on y-axis, then slope on x-axis is always be 0 and slope of y-axis is infinity. Obviously this is the graph of discontinuous function, because no graph is jumping from 0 to infinity. So this is the graph of discontinuous function. Student, these are the graph of continuous and discontinuous that we have discussed here. And now we will discuss one example of that how we can say that function is continuous, where the conditions can be fulfilled or how conditions can be held. Then we discuss example number 4. Example number 4 is f of x is equal to x square minus 9 by x minus 3 if x is not equal to 3. And secondly, they are saying 6 if x is equal to 3. And in this example, they are saying that you check continuity, you check the function is continuous at x is equal to 3. Mean x is equal to 3, we will check that whether function is continuous or not. And also they are giving second part on your book, page number 30. Inshallah we will discuss also, but we will discuss it later on. Then first part is f of x square by minus 9 divided by x minus 3 if x is not equal to 3, and 6 is x is equal to 3. Then you check that if we are going to check that whether function is continuous or not, then first of all we will check then first condition. Condition number 1 was f of c is defined, whether the given value is defined by that function or not. Then you check that they are saying that you have to check continuity at x equal to 3. Then in given condition you check that x is equal to 3, our answer is 6. So at x is equal to 3, f of 3 is equal to 6, which is defined. Understand that when we put value of x equal to 3, then we can get exact number, exact constant. There is exact one constant is there, that is our answer. It means that function is now defined, and we can give name equation number 1. Okay ji, we have checked first condition. Now second condition is that limit x approaches to c, f of x exists. That we have to check that whether left hand limit is equal to right hand limit, or not. Then we will write limit x approaches to 3 negative. There is no need of negative and positive, because in the question you check that only they are giving x is not equal to 3. So there is only one condition is given, they are giving. So we will put as by simple way that limit x approaches to 3 f of x is equal to limit x approaches to 3 x approaches to 3. It's mean that x is not equal to 3. So we can write x square minus 9 divided by x minus 3. Limit x approaches to 3, we can also write its formula x plus 3 into x minus 3 divided by x minus 3. X minus 3 will be cancelled with x minus 3, and our answer is limit x approaches to 3 into x plus 3. Now we will put the value of x, then we can get answer is 6. It's mean that limit x approaches to 3 f of x is equal to 6. We give name equation number 2. Now second condition also completed. Now by you check that when by holding condition number 3, that was limit x approaches to 3 f of x equal to f of c. Its first condition was f of c. f of c का आंसर हमारे पास क्या आया था 6. When we put the constant value, then our answer was 6. But after putting limit, our answer is same like first equation. Answer is here also 6. So we can write as by equation 1 and 2, f of 3 is equal to 6 is equal to limit x approaches to 3 f of x. So we can say that function f of x is continuous function at x is equal to 3. Student, in second part